I wanted to make a video of the things I learned during the first few weeks that I had my PM-25MV benchtop milling machine from Precision Matthews, which I must say I'm very happy with it, and Precision Matthews has been top-notch with customer service. I have a list here. I'm going to work down the list. The first thing I learned was that if you're concerned about lifting the heavy milling machine onto the stand, you can rent a beam lifter from the rental yard. A lot of people use a cherry picker and a strap. I saw the beam lifter at the rental yard and I thought, wow, that's perfect. What we did is we set the table on the beam lifter and we cranked up the beam lifter, and two guys lifted it onto the table very, very easily. And the beam lifter only cost $65, so that was a good investment. The second thing I learned was that the T-nuts that are provided in the Precision Matthews toolbox are too large for the slots on this table. The slots on this table are 12 millimeter, so you're going to end up using 1/2-inch T-nuts. I found those both in the Precision Matthews 52-piece clamping kit, which I show later in the video. I also found 1/2-inch T-nuts on eBay. With 1/2-inch T-nuts, you're going to find yourself using 3/8-inch bolts, at least in my case. So at another point, I found myself at the hardware store buying 3/8-inch bolts and washers. Working down my list, I learned where the locks are for the spindle and the X, Y, and Z axes. The spindle lock is here, which prevents the spindle from going up and down. See if it's unlocked, you could do like you do on a drill press. The X-axis lock levers are here and here. You can use either or both, depending on where you have room. The Y-axis lock levers are located over here, and you want to make sure those don't get in the way when you're cranking the Y-axis back and forth. Same thing with these. You want to make sure these aren't in the way when you're cranking the Y-axis back and forth. Have those levers out of the way. Finally, the Z-axis lock levers are located back here behind the motor control unit. And you can't see those because of the camera angle, and I apologize for that. The next item on my list is when you get this machine, the DRO will be set to metric. And I'm in the United States, so I use thousandths. That is very easily fixed by just hitting this button. It says millimeters inch. Just go like that, you're in millimeters. Like that, you're in thousandths. Metric to standard with one button. The next item I'm going to talk about is the power feed kit. And there's a lot to discuss about the power feed kit. It took me a lot longer to install than I expected. I had thought maybe my friend and I could take 4 hours to install it, and we failed. It ended up taking me about 12 hours to install it, which was frustrating to me because I was real excited about getting the mill up and running. And some of the things I learned are there's two paths to take when you install the power feed, the X-axis power feed kit. You can drill and tap your saddle, or you can choose the path that I decided to take, was to use the existing holes that are exposed when you pull off the zero that's on there. You already have two tapped holes, and you can modify the brackets that are included, which is what I chose to do. The benefit of that is that if you relieve the bracket that's behind there, and there's a picture at the end of the video, you still have access to the ball oiler. There's two brackets back here. The one bracket is thin, and it's the back of the limit switch. When I got it from Precision Matthews, the bracket was too long. So you can either cut it or do what I did, and I cut it and shortened it and re-welded it, and that way it fits. You're not going to use a bracket like it comes in the kit. It's just too long. Now this limit switch is a tight fit. The bottom of the limit switch will be about 1 millimeter above the Y-axis hand wheel, and the top of the limit switch, if you use the dust cover, will be just under your vise or swivel. I had to file a relief in this dust cover, and there's also a picture of that shown at the end of the video. A lot of people don't use the dust cover, and I can understand that, but if you file a relief in the back of the dust cover, it will fit. Continuing to talk about the X-axis power feed kit, it comes with these plungers that hit the limit switch to stop the mill from crashing. And when you get the X-axis power feed kit, you'll have to file or grind these slide-in T-nuts to fit in your dovetail slots. So be prepared to file or grind some slide-in T-nuts. Speaking more of the power feed kit, it has these brackets. This bracket and this bracket are both cast aluminum, so it's a little brittle. Either my friend or I cracked this bracket by tightening one of these bolts too much. So Precision Matthews was really good about sending me a replacement bracket, and I appreciate that. It was suggested to me that I use Loctite on these nuts, so I use blue Loctite here. And I tighten the bolts snug, just snug enough to get the job done with the blue Loctite in there. I did not use Loctite on these bolts here because you want to keep the option open to loosen these bolts and raise this up and down, which will adjust how much the teeth engage on the drive gear. In my case, I have it down flush and it's fully engaged so that the power feed has really good engagement. The cost I paid for that is my hand wheel is a little hard to crank. So if I make sure these are unlocked, cranking the hand wheel, it's a little harder to crank than the other hand wheels. And I don't mind that because I have good engagement for my power feed. The power feed has a potentiometer here. You can go from slow to fast. See, there's real slow for a nice surface finish. And then it's got a rapid, or you can turn it up really fast. And I'll just let that go and you'll see the limit switch do its job. So that's about all I have to say about the power feed kit. Just remember that it's real easy to adjust this up and down to make the hand wheel easier to crank or adjust how good your engagement is on the drive gear. And the X-axis power feed is an absolute must-have. So there's the limit switch doing its job. It prevented this from crashing. This would have crashed in about an inch. The next item that I learned was about how to use the fine control for the spindle. We're going to differentiate the spindle from the Z-axis, of course. And the spindle can go up and down. And to use the fine control, you need to engage this. Like right now, it's not engaged. And so when you turn this, it doesn't do anything. If you want to use the fine control, you need to make sure this is engaged. So if you tighten it all the way, when you tighten and loosen the fine control, you see this on the wheel. Now you don't want to leave that engaged all the time. To disengage it, you loosen this and it comes out. So now I can go up and down like you would on a drill press. When this is disengaged, this fine control doesn't do anything. So with regard to the key slot for the R8 Collet, and you'll see this in the manual, there's a slot here. And inside the slot, there's a set screw. And the set screw happens to call for a 2.5 millimeter hex key. The set screw can be found by rotating the spindle around until you see the set screw. Now, when I got my machine, the set screw was set too far in, so I was unable to thread my drawbar into my collet. So what I had to do was I had to back that out enough to where I could seat my collet enough to thread the drawbar, and then I installed the collet, and then I tightened the set screw just enough to get a slot for the collet. That set screw defines the slot for the collet. My next note is, when I first got the mill, I was so excited to use it, I had failed to learn how to calculate RPM. So I didn't have any idea. I remember from school, from bicycle frame building school, he said to divide 382 by the diameter of the cutting tool in inches. And I didn't remember that exactly. So when I went on YouTube, I learned that to calculate your RPM for your cutting tool, you look at the material of the cutting tool. In this case, it's high-speed steel. You look at the material that you're working on. In this case, it's mild steel. High-speed steel cutting tool and mild steel material, I use a value of 100 surface feet per minute. And the formula is surface feet per minute times 3.82 divided by the diameter of the cutting tool in inches gives you your RPM. So in this case, the value of a surface feet per minute for this high-speed steel on mild steel is 100 surface feet per minute times 3.82 divided by 0.75 gave me 509. So for this job I'm doing, I chose 509 RPM. The next item on my list is I want to talk about the ball oilers. I had a ball oiler vibrate loose when the machine was pretty new, and I called Precision Matthews, and they said to reinstall a ball oiler, you just press it back in. It's a press fit. You're not screwing it in. Precision Matthews at least makes 6mm and 8mm ball oilers. This machine is sort of small, and it takes 6mm ball oilers. And I don't know if I already mentioned this, but the ball oilers may be blocked. Well, they are blocked when you install the X-axis power feed kit. There's a ball oiler here, which I don't have access to anymore, and the same thing here. And that's not a problem at all, because if you think about it, the ball oiler that is covered by the limit switch is for lubricating the ways for the Y-axis. Actually, it's for the X-axis. And then the ball oiler here is to lubricate the lead screw and the hand wheel, maybe the ways. The point is, you don't need to use the ball oilers. You can just go in there and lubricate your lead screw or your ways or any mechanism at all just with your oiler directly. Just take an oiler and just lubricate whatever you want. Don't need a ball oiler. And now I'll show the tools that I've accumulated so far. So here's the tooling that I bought so far for my milling machine. You know, I bought a milling machine and a lathe, and that took up a lot of my money. I did the whole thing on a credit card, and at this point I don't have any money for any metrology equipment. So this is the 52-piece clamping kit that I got from Precision Matthews. It's 3/8 inch hardware. Here's my large V blocks that I got from Grizzly. It was about $60 for both, because I work with thin-walled tubing a lot. This is my 11-piece collet set, R8 collets, that I bought with the milling machine. This comes from Precision Matthews. I did order a chuck, which is still on its way. This is a parallel set, which I needed right off the bat. And I was confused about how to find a parallel set, because I'd go on Amazon, and for some reason I was attracted to the negative reviews and people said they were awful. And I ended up using the recommendations from Blondie Hacks on YouTube, the stuff she was using. because she seems to know what she's doing, so I bought the stuff that she had. This is my high-speed steel end mill set. I don't know when I'm going to ever use the 2-flute ones, because I usually work on steel and aluminum and titanium, which would include chromoly. So I don't even know why I bought the 2-flute, but that was a set she recommended, and maybe I'll find myself working on brass or Delrin one day. This is the extra drawbar that came with the milling machine, which I was really happy about. This is a solid machine piece. That's a shoulder. It's not a collar that's machined on there. It's machined. And this is the toolkit that comes with the milling machine. It includes an extra handle and just various hardware. This is the, they sent me some hex keys, and now I see there's some T-nuts. These T-nuts are oversized that come with, I guess they expect you to have larger T-slots. This is what I use for the, to install the drawbar. It doesn't work very well. I tried to find a socket, a female socket, but I can only find a male socket, so I'm still looking for a female socket. I'm not sure what that is. If it's 11 or 12 millimeter, I'm not sure. This is a spindle lock handle. And then I picked up some of these. These are going to be ground down to where they fit in the dovetails on the outside of the table. So we're calling those slide-in T-nuts. I got those on eBay. And then this is the oiler that comes with the PM kit. I filled it with 3-in-1 oil because I hadn't seen the manual yet of what sort of oil to use. And how I use this, trying to find a ball oiler here. I imagine everyone knows how to use a ball oiler, but this is how I do it. Make sure this is unlocked. Something like that. Obviously, I'd move that out of the way. Going back to the power feed kit, you can't really see my modifications, but when you get the power feed kit, you're going to want to really be patient and be prepared to either tap your saddle or modify the brackets that come with the kit. I didn't feel like tapping my saddle, even though PM recommended tapping the saddle. If you tap the saddle, these two bolts would bolt into your saddle. And this limit switch kind of almost gets in the way. The dust cover, a lot of people don't use the dust cover. I relieved the back of it, which I'm afraid you can't see. But I filed out a relief on the back of it, and I modified the brackets a lot, and I'll splice in a picture of that. It took a bit of work. When PM sends a kit, this bracket here is too long, so you have to cut it, and I cut it and re-weld it. You could just cut it, but I cut it and re-welded it. And the bracket back here that I'm going to edit in pictures of my modifications, it has to be ground down a lot because it obstructs the ball oiler, and I ended up bolting my brackets to the existing threaded holes that were used for a zero indicator. And I'll splice in a picture of that. So that's my PM-25MV, what I learned the first 2 weeks of owning it, and I really like it. Thanks for watching.